This is part 1 of a 3-part presentation. In this part, we introduce you to our project at Cisco on Programmable Seamless Virtual Clouds. In part 2, we will show you a demonstration of our prototype. In part 3, you will gain more insight into the details of Programmable Seamless Virtual Clouds. You, as an enterprise, may have a private cloud that is widely distributed over multiple geographic regions, with multiple on-premise data centers and sites. The resources in this private cloud may span over network segments controlled by multiple network service providers. These resources could be compute, storage, or network resources. In the demonstration we will show you in part 2 of this presentation, our resources are virtual machines. The boxes show client and server virtual machines. You may also have resources in one or more public clouds. In other words, you, as an enterprise, have widely distributed resources distributed over a combination of private, public, hybrid, or community clouds. You'll want to 1. Manage these resources as one seamless cloud, and 2. Divide the resources into islands of virtual clouds and deploy different distributed functions or applications onto those islands. But you'll want to do that without worrying about the complexity of the underlying infrastructure. Of course, there may be other tenants in a multi-tenant cloud, as you'll see in the demonstration in part 2 of this presentation. Let's look at creating islands of virtual clouds out of existing deployed clouds. You, an enterprise infrastructure as a service administrator, can select a set of resources and sites and bind them together to create a virtual cloud instance where you can deploy and run a distributed media application. In part 2 of this presentation, we will show you a demonstration that uses this virtual cloud instance where multiple widely distributed media servers and clients work together for a single purpose, for streaming video. If you want to deploy and run another application or function, such as a distributed virtual data center with its web, application, and database tiers widely distributed, you can create another dedicated virtual cloud instance. Based on your application needs, resources can be added to grow the virtual cloud instance. Similarly, resources can be removed to shrink the virtual cloud instance. In true cloud fashion, you grow and shrink the instance on demand and programmatically. Any addition or deletion just attaches or detaches the resource or site to or from the seamless cloud, which means they become accessible or inaccessible from within the seamless cloud. Most importantly, if you delete a resource or site from the seamless cloud, the underlying resource doesn't get deleted or disconnected from the network. Rather, it's simply no longer reachable from within the seamless cloud. Your enterprise resources are widely distributed because you may not be able to move huge amounts of raw data due to, for example, performance reasons, regulatory reasons, security reasons, or high availability reasons. But you still want to run a distributed application on those resources and data, which aggregates the data and then moves the aggregated data. Or your data center tiers, the web, application, and database tiers, may be distributed over multiple clouds and sites for the same performance, regulatory, security, or high availability reasons. You can conform to these performance, regulatory, security, high availability, and other requirements by controlling reachability. You can restrict reachability to the California and New York regions, for example, during the daytime. We call this an isolation domain. You can restrict reachability to the Texas region by creating a separate isolation domain. You can make California and New York and Texas all reachable to each other on demand or based on a condition. An example condition might be when it is cheaper to do so. Another example condition might be when the aggregated results from California and New York and the aggregated results from Texas should be merged. Even though there is a widely distributed complex network underneath the seamless cloud, the tenant sees one seamless subnet. We have developed a framework that has 3 main components. First is the seamless cloud graph abstraction that can be used by a tenant to create, read, update, and delete seamless clouds in a simple way as visualized in our 3D graphical user interface. We call this abstraction the cloud squared graph abstraction, since it's a cloud over existing cloud resources. The second component of our framework is a REST API that incorporates the cloud squared graph abstraction. The third component of our framework is the seamless cloud engine that takes the cloud squared graph sent through the REST API and realizes seamlessness and isolation in the infrastructure by programming the physical and virtual devices. That was a brief introduction to our project on programmable seamless virtual clouds. This is the end of part 1 of a 3-part presentation. Please go to part 2 of our presentation.